Hello everyone, welcome to Java programming series. If you're new to Java or looking to get better at it, you're in the right place. In this playlist, we'll cover all the important parts of Java programming. We'll start with the basic stuff and then we'll slowly move to more advanced topics. Each video will build on what we learned in the last one, making it easy to follow along. We'll go step by step, and I'll make sure to explain everything in a way that's easy to understand. So, if you want to learn Java, whether for school or work or just for fun, make sure to follow along with this series. Don't forget to subscribe so you don't miss any videos. So let's get started. Uh, when we talk about derived classes in Java, we are referring to a key concept in object-oriented programming known as inheritance. This concept allows one class known as the derived class or a subclass to inherit attributes and methods from another class referred to as the base or superclass. Suppose we have a basic class basic class called person. This class contains attributes that are common to everyone in a school environment, such as name, age, SN. And now within a school, there are specific types of people like students, teachers, and staff, each with their own unique attributes and behavior. Instead of creating entirely separate classes for each type from scratch, we can create derived classes that inherit from the person class. Let's take student as an example. For the derived class, a student is a person, but with additional attributes and perhaps methods that are specific to students. These might be like student ID, GPA, and a grade. So in Java, the relationship is again established using the extends keyword. The declaration class student extends person means that student inherits all the attributes and methods of a person while also introducing its own unique elements. So similarly, when you have a teacher class that also extends person, including the attributes like employee ID, salary, and number of years worked. So each of these derived classes retains the foundational elements of the person, ensuring that you don't need to rewrite common attributes like name and age for every type of person in the school system. So this approach shows the power of inheritance in object-oriented programming, and it allows for more organized, scalable, and maintainable code base. You can easily add new types of people to the system by creating new derived classes, and any changes to the person class automatically reflects to all its subclasses, ensuring consistency and reducing the chances of errors. So using derived classes in Java, as demonstrated with this school management system example, is a key strategy in efficient and effective object oriented programming. It simplifies code management and paves the way for more complex applications. And the next topic is inheritance. Inheritance is a cornerstone of object-oriented programming in Java. It allows a derived class, which is also known as subclass, to inherit properties and methods from another class known as the base class, also known as superclass. This concept is fundamental because it enables hierarchical classifications. An object of a derived class has access to its own public members as well as the public members of its base class. This design promotes code reusage and a logical structure within the program. Uh, in a derived class in Java, a derived class is declared using the keyword extends. Uh, let's look at the syntax for it. So basically, class derived class extends So this simple yet powerful statement establishes an inheritance relationship. Let's look at an example. Um, if we define class produce item extends generic item. So here the produce item automatically inherits all the accessible attributes and methods from the generic item, allowing for extended functionality and specialization. So, Java's inheritance model supports various scenarios. First one is multi-level inheritance. A derived class itself can be a base class from another class. For example, let's take another example for multi-level inheritance. Class fruit item extends produce item. So this creates a new class which is called fruit item that inherits from produce item, which in turn inherits from the generic item. This forms a multi-level inheritance chain, allowing for increasingly specialized behavior. Uh, and the next one is hierarchical inheritance. A single class can act as a base class for multiple derived classes. Uh, let's take another example for hierarchical inheritance. So, class frozen food item extends generic item. So here, the frozen food item and produce items are both derived from the generic item. This scenario is common in real world modeling where different subclasses share a common parent, uh, but in a specific aspects. So that's about hierarchical inheritance. And the next one is single inheritance. Java restricts, let's go back to the presentation. So, single inheritance, Java restricts a class to inherit from only one base class, attempting to inherit from multiple base classes, as an class house extends property will lead to a compiler error. This constraint simplifies the inheritance model and avoids complexities like the diamond problem, ensuring clarity and consistency in the inheritance hierarchy. So, inheritance in Java is a mechanism that promotes code efficiency, reusability, and a clear hierarchical structure. It allows for the creation of a specialized classes without the need to replicate code, leading to a more organized and maintainable code base. Understanding these inheritance scenarios is crucial for effective object-oriented programming and design. The next topic is member access in inheritance. In Java, in Java's inheritance, understanding how derived classes interact with their base class is crucial. So let's understand this concept. Imagine a derived class as a child in a family. and the base class as a parent. So now the child, which is derived class, can naturally access and use what's publicly available in the house. House is the base class. But if the parent has some private belongings, the child can't access these directly. This is similar to how derived classes access public members of a base class, but not the private ones. So that's uh, that's how it works. And protected members, this is a special case. Now there's a special scenario. Think of a protected family heirloom. This heirloom is not just for the parent, but it's accessible to the children and even to close relatives living in the same house in the sense same package. So in Java, protected members act similarly. They are accessible within the class they belong to, and in all its derived classes, and also to other classes in the same package. This is the strategic choice for a programmer when designing a class structure. So let's apply this with an example. Suppose we have a business class with the private details like name and address. Now you create a restaurant class that extends the business. If we want restaurant to access the name and address, we can't keep them private in business. Instead, we make them protected. By doing so, restaurant inherits these details, making them usable while still keeping them away from the public access. So that's another example. And there are few access levels in Java. The first one is private, uh, which are also called as access specifiers. Private is like personal diaries, accessible only within the class where they are declared. Protected, as we discussed before, it's like family heirlooms, like accessible within the class in a derived classes and in the other classes of the same package. And the public, which is open to all, like a public park, accessible by any class. And no specifier. This is a package private, like a shared space in a housing complex, accessible only within the class of the same package. Uh, and the last topic in this is class visibility. Uh, Declaring a class as a public means it's like a public figure, uh, and known and accessible everywhere. Without a specifier, it's more like a private citizen, recognized only within its local community or package. So understanding these access levels and class visibility is important for effective Java programming. This knowledge helps us design secure, organized, and effective Java applications. The next topic is overriding member methods in Java. In object-oriented programming, in Java, method overriding is a powerful feature that enhances flexibility and functionality in inheritance. When a derived class has a method with the same name, parameters, and the return type as the method in its base class, this is called method overriding. It's like updating a family recipe passed down through generations, and the core remains, but you add your unique touch. Uh, and Java provides helpful tools for this. The override notation. So placing the override above a method signals that you intend to override a method from the base class. This is not just a good practice; it's a safety net. The compiler checks if there truly is a method to override in the base class, and warns you if something is missing, like a typo or mismatched parameters. Think of it as a double check mechanism, ensuring you indeed updating what you intend to. So the difference between overriding and overloading. It's crucial not to confuse overriding with overloading. Overloading occurs within the same class when you have multiple methods with the same name but different parameters. Overriding, on the other hand, involves two methods with the same name and parameters but in different classes. Uh, it's like a base class and it's a derived class, and sometimes you want to use the functionality of the base class method and add more in the derived class. This is where the super comes in handy. Like by using super dot method name, you call the overridden method from the base class. It's like acknowledging the original recipe before adding your ingredients. And A common pitfall is accidentally creating a recursive call by omitting super. If you just call, like, let's take an example, get description method. If you just call get description inside overriding the get description method, you end up with a loop where the method repeatedly calls itself, never reaching the base class method. Always remember to use super when you want to call the base classes method. So method overriding in Java allows derived classes to provide a specific implementation for methods inherited from their base classes. It's a fundamental part of Java's inheritance model, enabling polymorphism and more dynamic, flexible code design. And the next topic is object class. In Java programming, the object class holds a special significance. Let's discuss what makes this class so foundational and how it affects the classes you create. Think of a think of the Java class as the foundation stone of a building. It's the base class of all the Java classes, but it stands alone without a base class of its own. So this means every class you craft, be it a straightforward utility class or a complex business model, is inherently a descendant of the object class. So now the object class is has several methods, but two stand out of for their frequent use and overridable nature: the toString and equals. So the toString method, it's all about identity here. By default, toString method gives you a string to combine the class name and the object's hash code, which is a unique identifier of sorts. Picture it as a default ID badge every object wears. However, this default representation is often not very informative, so many classes choose to override it. And the equals, this method is a bit like asking, are you and I the same person? By default, equals method checks if two references point to the exact same object. It's not about comparing contents or states. It's about comparing addresses in memory. And overriding toString in classes. In your class hierarchy, when you override toString method in a base class like the business, you are essentially customizing this ID badge. Maybe now it displays the business name and address. However, when a derived class such as restaurant does not override toString method, it inherits this behavior from business. So, but what if restaurant decides to have its version of toString method? Here's where it gets interesting. Restaurant can override toString method and use the super keyword to tap into the business class version. This way, it starts with the business name and address, and then it then adds its unique flavor. For example, the restaurant rating. So by overriding toString in both the base class and derived classes, you tailor how your objects express their identity. This is not just about making debugging or logging more informative. It's about giving your objects a voice that speaks their state and purpose more clearly. So The object class in Java is more than just a superclass. It's the template that gives structure to all your classes. Understanding and utilizing its methods, especially toString and equals methods, is crucial for making your classes more intuitive and your code more readable and maintainable. Next topic is polymorphism in Java. Polymorphism is a concept in Java that allows you to perform a single action in different ways. The word polymorphism comes from Greek meaning many forms. In Java, it refers to the ability of a variable, function, or object to take on multiple forms. It's like having a personal device that can function as phone, camera, or a calculator depending on what you need at that moment. In programming, this flexibility allows you to design more adaptable and maintainable code. Compile time polymorphism. Uh, the first type of polymorphism we encounter in Java is compile time polymorphism, also known as method overloading. Imagine you have a toolbox with tools that have the same name but serves different purposes based on their size or shape. Similarly, in Java, you can have multiple methods in a class with the same name but different parameters. The compiler at the compile time decides which method to call based on the method signature. So method overloading allows us to use the same method name for different ways to perform an action, making our code cleaner and more intuitive. And runtime polymorphism, which is primarily achieved through method overriding. This happens in inheritance when a derived class has a method with the same name as one with its base class. It's like giving your own spin to a family recipe, and the method in the derived class overrides the method in the base class. And the decision about which method to call is made at runtime. This form of polymorphism allows you to define a behavior that's specific to the derived class, providing more dynamic behavior to our applications. So polymorphism in Java enables us to write code that is flexible and easy to extend. It allows you to treat objects of different classes in a uniform way based on their shared characteristics, leading to more effective and easily maintainable code. And array lists and abstract classes. So in Java, there's a powerful concept that stems from the fact that all classes are derived from the object class. This concept allows us to create versatile collections like array lists uh, that can hold objects of various types. Think of an array list as a dynamic array that can grow and shrink in size. Now imagine that it can hold not just objects of a single type but any object. This flexibility is a direct result of runtime polymorphism, which we just discussed. And runtime polymorphism in Java allows us to treat objects of different classes in a uniform way. So when we create a array object or array list of objects, you can actually add to it any object that belongs to any class derived from object, which in Java is every class. So this means your array object can hold a business object, a string, an integer, and so on, all together in the same list. It's like having a mixed bag of various items, each with its unique properties and behaviors. Uh, and when it comes to abstract classes, in the Java's object-oriented programming, abstract classes play a crucial role. These classes are like the blueprints of other classes. They define a set of methods and properties that other con- concrete classes must implement. But unlike regular classes, you can't create instances of abstract classes. They're like a set of rules or a contract that other classes agree to follow. So some of the key features of object oriented programming and the role of abstract classes is, Let's before diving into abstract classes, let's briefly touch upon three foundational features of object-oriented programming, which are first one is classes. Classes, they encapsulate data and behavior, forming the building blocks of for objects. And inheritance is this feature allows one class to inherit properties and methods from another, forming a hierarchy. And abstract classes fit into this hierarchy as a special kind of class that outlines methods, but often does not provide a complete implementation for them. And when it comes to sorry when it comes to abstract methods and abstract classes, in an abstract class you'll find abstract methods. So these methods are declared but not implemented. They're like a promise that any subclass must fulfill. For example, abstract double compute area in a shape class specifies that any subclass like circle or a square must provide its own method to compute the area. And an abstract class is declared with a keyword abstract. It sets the stage for subclasses, dictating what methods they should have. However, you cannot create an object of an abstract class directly. It's a concept, not a concrete entity. And the difference between abstract and concrete classes, contrast this with the concrete classes, the normal classes we use to create objects. A concrete class is fully implemented class and can be initiated. It may inherit from an abstract class, and when it does, it must provide implementations for all the abstract methods declared in the abstract class. So a concrete circle class would define exactly how to compute the area, fulfilling the contract set by the shape abstract class. So abstract classes in Java are a powerful tool for defining a common interface and ensuring a certain level of uniformity across various subclasses. They help in reducing code duplication and encourage a cleaner, more structured approach to programming. So when we talk about relationships in Java, there are two primary types: is A and has A. Uh, is A is about inheritance and defines a relationship where a subclass is a type of the parent class. For example, a circle is a shape. This is the inheritance in action. Like on the other hand, has A refers to composition, where a class is composed of one or more instances of other classes. Like for example, a mother info class might have a first name, which is a string object, and children data, which is a array list of the child info objects. So here mother info doesn't inherit from the string or array list, but rather contains them. So that's the difference between is A and has A. UML diagrams, the full form of UML is Unified Modeling Language. It is a visual language for modeling the structure of software systems. UML class diagrams are particularly useful for visualizing the structure of a program, including classes, their attributes, methods, and relationships. In UML, inheritance is represented by an arrow with a solid line and an unfilled arrowhead pointing towards the superclass. The abstract classes and methods are denoted in italics. These diagrams are a standard way to explain the design of the program, making it easier to understand and communicate the structure. And interfaces in Java. Moving to interfaces in Java, think of them as uh, const, contracts that a class agrees to follow. An interface declares object method that any implementation class must override and define. Unlike classes, interface don't hold states. Uh, which are variables. So but provide a form for the class variable. Creating an interface is done with a interface keyword. For example, we have interfaces like drawable or drawable ASCII. They'll specify methods that a class must implement, providing a clear structure for how the objects of the class behave. So that's the last topic of this video. uh, let's uh, let's discuss what all topics we learned in this video. The first topic is inheritance and derived classes. We explored the concept of derived, also called as super subclass in Java. We demonstrated how derived classes inherit properties and behaviors from the base classes, also known as superclass, facilitating code reusage and hierarchical class organization. And we also discussed about access control. We discussed how derived classes access members of their base classes. Also emphasized the distinction between public, private, and protected members, and the role of access specifiers in object-oriented design, and overriding member methods. We also covered the concept of method overriding, where a method in a derived class has the same signature as the method in its base class. Uh, we also highlighted the use of override notation and the difference between overriding and overloading. And we introduced the object class, the root of the Java class hierarchy. We focused on its fundamental methods like toString method and the equals method, and the importance of overriding these methods in custom classes. We also discussed about polymorphism in Java, including compile time and runtime polymorphism. We also discussed how polymorphism allows objects to be treated as instances of their superclass in certain contexts, increasing flexibility. And we discussed the use of array list to store objects of various types, thanks to all classes being derived from the object class. We also touched on the dynamic nature of the array lists in handling objects of different classes. And we discussed about abstract classes and methods, which define a template for other classes, and how we discussed about how abstract classes guide subclass design but cannot be initiated themselves. And we also introduced UML, Unified Modeling Language, as a tool for visualizing class inheritance and relationships. Also described how UML diagrams are used to represent class structures, including abstract classes and inheritance relationships. And we also discussed about easy and the difference between easy and has a relationships. We differentiated between easy relationship, which is inheritance, and has a relationships, which is a composition. We classified how these relationships are used to design classes in more structured and logical manner. And the last topic was interfaces. uh, we concluded with interfaces detailing how they provide a contract for classes to implement specific methods. And we discussed the role of interfaces in defining behavior and enhancing flexibility in class design. So yeah, all right, that wraps up our session for today. I hope you found this video helpful and that it added to your understanding of Java programming. If you have any questions, feel free to drop them in the comments below. I'll do my best to answer them. And don't forget to subscribe to the channel for more videos like this. We have a lot more interesting topics to cover in this Java series. Thank you.